34 years ago, on this very day, in the middle of the Doctor Who episode, Horror of Fang Rock, a local Chicago TV station signal was hijacked for about 90 seconds by a broadcast from someone wearing a Max Headroom mask. While signals have long since gone digital and we have encryption that makes such attacks more difficult, there are plenty of modern parallels and takeovers of social media accounts. We've just gone from transmitter power to SIM swapping. But I mostly wanted to mention how cool the real Max Headroom show was, and wonder if the next 90-second dystopian cyberpunk interruption is only a TikTok away. Which means this week we talk with Randall from Cosmonic about WebAssembly and the CNCF's wasmCloud project to help developers turn any code into an app for any browser, anywhere. In the news segment, CVEs for CSPs, C2 for malicious Python packages, diversity for bounty researchers, secure defaults for shared responsibility models, and more. Catch the wave and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Is your mobile app really secure? New vulnerabilities pop up every day, and malicious actors look for easy targets on app marketplaces to exploit. Securing your app's valuable IP and data is critical. GuardSquare security solutions are built for developers and protect your app at every stage in the development lifecycle. Multiple layers of protection prevent reverse engineering and automatically detect tampering, making your app a difficult target for attackers. Learn more at securityweekly.com/GuardSquare. Contrast Security enables organizations to secure their applications from development to production. By embedding security sensors within software, Contrast automatically and continuously detects vulnerabilities in both custom and open source code while developers write code, providing them with context-specific how-to-fix guidance for easy and fast remediation. At the same time, by identifying only true vulnerabilities that pose risk and eliminating those that do not, Contrast empowers developers and security teams to prioritize and focus on only those vulnerabilities that matter. Learn how Contrast can help you secure your applications from development through production at securityweekly.com/contrast.
This is episode 175, recorded November 22nd, 2021. I'm your host, Mike Shima, and I'm 20 minutes into the future with my co-host, John Kinsella. Hello, Mr. John Kinsella.
Dude, you're making me feel old with all these references, things like to Max. What do we have for a Black Friday sale today, Mike?
We have a sale on cross-site scripting. Going, gone. Get it now because it's never going to go away. I don't know. That's the best I can come up with. I'll pick on you for the news segment. We'll see what we can do better. Thanks, John. Let's see, what else do we have? We also have, throughout 2022, CRA's Business Intelligence Unit will be releasing research reports on the top topics across the security industry. Our first report will be on third-party risk and the supply chain, which sounds like an awesome funk band. To participate in the survey, please visit securityweekly.com/third-party risk. The results will be shared at our third-party risk e-summit in January. Security Weekly Unlocked will be held in person this December 5th through 7th at the Hilton Lake Buena Vista. Keynotes from Alyssa Miller, John Strand, Leslie Carhart, Dave Kennedy, and Meryl Vernon. Visit securityweekly.com/unlocked to register and check out our exciting lineup. Liam is a serial entrepreneur, venture capitalist, and engineer with a sharp eye for identifying transformational projects. His past startups include Bro, now Zeek, OS Query, Cloud Custodian, and building the very first Kubernetes company, Critical Stack. He has sold numerous companies and today is enthralled with WebAssembly, especially CNCF wasmCloud. Today, he is the CEO of Cosmonic. Hello, Liam. Thank you for joining us.
Thank you guys so much for having me on. I'm so excited today to talk about WebAssembly and all the amazing things that are sort of tipping up to be part of the next epic of computing.
It is quite epic. Your background is quite epic as well. And I just wanted to kind of acknowledge that too, that you started off with Zeek, very deep at the network layer, OS Query onto systems, then into clouds, then into containers, and now WebAssembly. But to sort of set the tone, I think, for the topic of WebAssembly isn't really just the browser, and it's not like it's a tiny part of that. I think WebAssembly might encompass that entire journey.
Yeah, I think it's important for us to consider, where we started. If you go back to where most of us began our careers, we were building system images that included things like device drivers for SCSI cards. And we said, hey, this is crazy. I want to save money. I want more portability. I want higher density. Let's virtualize the CPUs. And when we got there, we had the rise of VMware and then the rise of AWS after that. And we said, well, hey, this is crazy. I don't want to, I'm shipping software to the cloud. The operating systems are different. It's hard to keep this consistent. I want to virtualize the OS here. And we really started to migrate to containers. And then we had another realization. We said, hey, why do I want to be stuck in one cloud? I want portability. I want cost savings. I want to be able to have high density everywhere. So we virtualized the cloud APIs with Kubernetes. And WebAssembly is a technology that's very similar to other things that have come before it. It is the fourth official language of the web. And much like JavaScript, it was originally designed for web browsers, but its sandboxing capabilities means that its impact will likely be bigger outside of web browsers than within the browser. And the way that I like to think about WebAssembly is that it's sort of a virtualization step for an individual process. And what's nice is that we now have a format that is portable not only across CPU architectures and into places where we don't really even think of CPUs like browsers, but it also gives us a security model that's portable as well. Containers are, pin their model to the idea of a Linux process and Kubernetes. And ultimately, there's a lower bound. And there's lots of places where we want to run our code, but we aren't running either Linux or Kubernetes.
Yeah, I think there's definitely a lot there's many paths we can go into, but let's start, as we're AppSec, on those security angles, because one of the things you mentioned that WebAssembly is like JavaScript, and it can be executed within the JavaScript engines, but it is actually, its own distinct beast. But when we start talking about the browser, start talking about JavaScript, I can imagine a couple people might get worried, especially if we're talking about WebAssembly as yet another kind of abstraction layer within its own process and sandboxing. But help us pick apart this sandbox a little bit and these abstractions. How much of this is, do I need to worry? Just use a little bit of a contrived example. I write a stack-based buffer overflow in a very simple C code, compile that through my LLVM into WebAssembly, and now I've got something that's potentially buffer overflow dangerous within the browser. Let's talk about those aspects maybe for a bit.
Yeah, absolutely. Look, let's think about the sort of core value proposition that we're hearing with WebAssembly. It's truly this write once, run anywhere, and we heard that before with Java, with Silverlight, with Flash, and let's just start with why WebAssembly is different. WebAssembly is an open W3C standard, which means that this is community developed and it's already baked into all of the browsers that you love today. It's supported by the major browsers. It works on mobile devices. And I would emphasize that this is far more than a browser technology. But security was designed in by default here. So as you sort of implied, WebAssembly doesn't include a language like Java. It's polyglot, which means that I can bring code from multiple languages into the ecosystem. But it has another incredible property when we're thinking about it from the concept of a virtual CPU, and that's that a WebAssembly is inherently denied by default, which means that much like the setcap tool on Linux, for any of the old Linux gurus out there, you really need to, the idea of WebAssembly is that as a process or as an execution format, I do not inherit the permissions of my parent. Any capabilities that I need to have to be granted, I need to be granted access to. And the application framework that we build extends that into higher order capabilities, which is called wasmCloud. So let's take your example where you have some sort of an exploit. There are things that are baked into WebAssembly that work to prevent that. And WebAssembly is still a new technology. But when we even think about the impact surface, because you have this specific grants of capabilities to the process, you're already specifically limited to what you have access to. So from a breakout perspective or from a lateral movement perspective, within the concept of execution here, you're already starting with a significantly smaller scope.
Yeah, I think some of the things that it really appealed to me about WebAssembly was the attention to how they're controlling the stack, how they're implementing strict control flow integrity. So they've actually learned from lessons of the past, things like return-oriented programming. That when DEP and ASLR came out, all these that was potentially speed bumps, but all these libraries that processes were pulling in had very predictable function addresses. So you could just pop in and out of those and still get your exploit to work. But now with CFI and this, how WebAssembly enforces that, it's a lot more difficult, if not completely impossible. Same thing with, and I believe they're pretty good about saying, especially I come from the C and C+ world, no undefined behavior, which is can be a benefit for optimization, but a massive detriment for security. So these are some of the details, really down in the weeds, if you will, that seem like a really positive aspect for security.
Yeah, absolutely. Look, WebAssembly is certainly a relatively newer technology, and that means that there, like all things human, is going to be flawed. And there are undoubtedly going to be discoveries. But I think what is really amazing about WebAssembly as a core technology and as part of a movement is that this is a movement that transcends any one particular set of vendors. The technology itself was originally developed at the skunkworks that is Mozilla Labs, and now much of the team has put their weight behind an open group called the Bytecode Alliance. And then I happen to be the chair of the Cloud Native Computing Foundation WebAssembly Day that really focuses on the intersection of WebAssembly and the enterprise, and thinking about how do we take this amazing innovation and how do we operationalize this inside of our microservices, inside of our enterprise applications, to really help to deliver on the Better Together story and make this compatible with the technologies that enterprises are building upon today.
That's a great point for us to say, what are those, business use cases that WebAssembly is really appealing for? Because I kind of started off with a little bit that made up exercise that no one's really going to rewrite the smashing the stack for fun and profit exercises, in WebAssembly, other than maybe as a something fun. And I've seen Doom. I think that was one of the first WebAssembly examples that I ever came across that was pretty awesome in the browser. But Doom aside, even getting outside of the browser itself, help us understand, what are these microservice use cases? Why would I want to use WebAssembly rather than just stick with my Go microservice?
Yeah, if we think about WebAssembly as a language for the web, and you think about how we use the other languages for the web, things like HTML, CSS, JavaScript, those are the other three. We typically start with frameworks. And I was at a very large financial institution a few years ago. I had sold the very first Kubernetes company there, and we started to analyze this problem at huge scale. And we saw WebAssembly as a part of unlocking and two of our biggest challenges. And the first two challenges that we have in today's ecosystem around containers is the sort of lack of portability. And when we say portability, we mean, with this first challenge, the ability to take the same code and execute it across different CPUs. When you think about inside the public cloud itself, you have Amazon launching ARM CPUs that they sell at lower prices. You also have Alibaba launching their own ARM and RISC-V CPU architectures. Amazon is now followed up, and they have a new machine learning-oriented processor. So organizations are dealing with more and more distinct places where they need to bring the same business logic. So that was the first challenge. The second challenge was the challenge around a lack of a portable security model. And WebAssembly's deny by default is something that works well inside the web browser, and it's something that works well on standard hardware or on an edge device, or running in a container, running on a managed Kubernetes service, or running on your own. It was a security model that was available everywhere. But with the enterprise, we specifically saw an even bigger opportunity. And that was when we're building our microservices and we're building our applications, we have portable execution, but we don't have portable libraries. So we introduced a framework to our project called wasmCloud that's now in the CNCF that essentially virtualizes the libraries. So when we think about our stack, we virtualize the CPU, we virtualize the operating system, we virtualize the cloud APIs with Kubernetes, we're virtualizing the process with WebAssembly, and now we have the ability to virtualize the libraries. And from a security perspective, this is a huge implication, because what it does is it pulls all of that boilerplate code that has a natural life cycle of needing to be updated and maintained for vulnerabilities. It pulls all that vulnerable code out of this tight coupling that we give it with our business logic. Let's take some fictional microservice that needs to calculate the interest rate we want to charge on a loan, or something else along those lines. There's no reason to have that logic specifically tied to a web server or to a particular type of a database. In fact, it sounds as crazy to me today as tying it to a specific RAID controller or a specific Dell or HP piece of hardware. So I think this is a very fast-moving space, but in the broader term, I think that WebAssembly will have a huge impact on what we're doing inside of web browsers. But for the enterprise, it's going to start with the tremendous impact that it has on microservices.
Yeah,
so
go ahead.
One of the things when you always run into a trade-off when you decouple code and make try to make your architecture be a little looser like that. So what does that look like in reality so far for folks that are using wasmCloud? Is it taking a lot of work for them to be able to use a virtualized library? Are they having to do a lot of rewrite or a lot of modification of their code, or is that more of an easier user experience or a dev, I guess, experience for those folks doing that?
That's a phenomenal question. And let's maybe compare and contrast this a little bit with containers, because I think that's a helpful mindset that most people understand. Now, containers were adopted very quickly for, I think, two reasons. One, the core technology that made them work was baked into the Linux kernel. And therefore, just by installing Docker, you could now take advantage of C groups and namespaces. And WebAssembly is a similar opportunity. WebAssembly is already baked into all of the devices that you're already using today. So I think we've got some parity there. Now, where these technologies differ beyond the obvious technology differences is that, using WebAssembly and more specifically wasmCloud in your app is going to be a greenfield activity. Now, it's compatible in your brownfield that you can use it, but with containers, you could take an application and just repackage it into a container, and that's not something that is as easy to do with WebAssembly as a technology. There are companies that are out there that are using WebAssembly as more of a pure virtual machine and compiling full stacks down to it. I think there's a company called Chirp that's doing something similar to that. However, I think that those are less interesting than the cases where we're doing it. Now, with wasmCloud, it's essentially an actor model. And this decoupling of business logic from capabilities in some ways is easier and in some ways is harder. Now, you can reuse your existing libraries that you have that implement your business functionality in whatever language you use, but you do need to essentially build a new application. Now, where this is powerful, though, is that over the medium to long term, the cost of maintaining these libraries in an individual application is very expensive. We spent time analyzing this at tremendous scale across thousands of microservices. And the shocking thing that we realized was that in this business's microservices, over 95% of their source code was boilerplate. And these were, in this particular case, this was a Java Spring Boot based company. So these were, a framework that they would give developers to start that had all of the sort of enterprise checkboxes already baked in. It had, logging and introspection and, key storage and, this long list of things that you would need to do as part of a common checklist. But it became a curse to the developers because while it accelerated them initially on development, the cost of maintenance meant every month that they were patching these high, medium, and lows, and not just once at the enterprise level. They were having to repatch these across thousands of specific applications. So I think that there are some trade-offs when you're looking at this from a life cycle point of view.
Yeah.
Interesting.
That That also kind of touches on the engineering aspects is where my mind is going to now on where this code is executing, because we've understandably focused a lot on the security, the sandboxing, the abstractions, and virtualization. But one of the things too, when you start to mention virtualization, now there's potential performance impacts. Abstracting one layer, yet another layer, yet another layer. But the WASM could be run and like that sort of Lambda function as a service within the cloud, within a container, but it's also within the browser, or even, there's a trend towards edge computing, I think is one of the terms. How does this kind of influence either what WASM is good for in terms of it should just be always stateless and only ever stateless type of apps, or handling secrets, or what about security guarantees of mutual authentication between these microservices built in WASM?
Yeah, look, I think you absolutely nailed it, and that there is a time and a place where we would adopt particular types of technology. Now, WebAssembly and wasmCloud specifically really bring some interesting characteristics to bear on a problem space. And one of the most interesting is that these little, small, tiny WASMlets, if you will, are incredibly tiny, and they have an incredibly fast cold start time on the order of microseconds. Now, if we compare that to the start time of even highly optimized containers, which can take seconds, it means that we have a sort of a new paradigm that's here before us. Because across enterprises, when you're looking at a frequency analysis, you will typically have some jobs that are very long running, that take hours and hours or days to execute. And those applications might eventually, the sort of efficiency that I gained in a fast startup time would be eclipsed by the slight performance penalty I get. And it is very slight on the order of magnitude of a percentage point or so that I would get from operating inside of WebAssembly. But when we look at the vast majority of functions as a service that execute in enterprises, Datadog released this fascinating report where they started to talk about this rise of the sub-second function. And in fact, at most large organizations, functions are very short running. So I think there's a real sweet spot here when you're thinking about building your apps and why you would deploy things into wasmCloud so that you can run that same code across the edge. Now, that's the kind of theory, but what I think is really incredible is watching what the user community is doing. We had a very large EU financial come to the Kubernetes KubeCon Cloud Native WebAssembly Day this year, and they did this incredible demonstration where they're running the same code in GCP and in AWS, and then they do live failovers on stage. And it was because they have these application libraries virtualized, and they could make locality, specific choices depending on where they were executing, that they were able to seamlessly fail back and forth between these clouds. And from a developer experience, it was wonderful because they didn't need to become experts in all of the intricacies or nuances of the lower level connectivity. I would really recommend operators out there that want to see their peers, how they're using WebAssembly in production, to check this talk out. And perhaps we can link that into the show notes if that's appropriate.
Great comment. Yeah, we'll dig up that link and drop it into Discord and show notes as soon as we can. I want to take a chance there to also, we talked about wasmCloud, but maybe let's dive into a little bit more. And I think this is a little bit also what John was touching on, is that, if we start off with just WebAssembly, there's a lot of, I think, greenfield, but there's a lot of, bytecode that gets built up, but not a lot of primitives. There can be some sharp edges, and there also may not be some capabilities that are not abstracted. So not every single C application out there or other language could go straight into a WASM. So tell us a bit more about what wasmCloud, what does this framework provide that actually helps remove some of the sharp edges, and what remains?
Yeah, that's a great point. When we think about, from a mental map, WebAssembly on day one is a virtual CPU. And it is somewhat limited in its capabilities in that, it doesn't have the ability to work with complex data types, as an example. So when we were thinking through this problem a few years ago, wasmCloud has been on the market under a few different names as we've sort of iterated and grown the community for over 2.5 years now. And we really started with this idea of thinking about like how people use HTML. If I want to build a new application for the web, I'll start with something like React or Vue, because there's a lot of common features that I will need: the ability to have menu bars, to display modalities, to have little toast pop up at the bottom of the screen. And we took that same approach in building wasmCloud. And so what we did was we really built an ecosystem for you that lets developers simply focus on bringing their business logic to a functioning application. And we give you the sort of standard toolkit, the Swiss Army knife of what you will, of common Lego blocks that you can plug into your application at runtime. So for example, if you want a web server or a message queue or even database accessibility, you simply just declare that you want those Lego blocks. And then at runtime, the appropriate choice is made as to what capability you're specifically bound to. And it gives you this experience of being able to implement POCs very quickly, build things locally as like a monolith, but then to distribute them and run them however makes sense in the moment or in a point in time. So we're really thinking through that developer experience, and we really want to enable WebAssembly in the way that Docker enabled containers. C groups and namespaces were in the Linux kernel from 2007, but it was 5 long years before somebody made that a great user experience so that people could simply sit down and use that power today. And what wasmCloud does for WebAssembly is very similar to what Docker did for containers. It gives you an ecosystem, it gives you template generators, it gets you up and going very quickly so that you can start to take advantage of these powerful value props that WebAssembly brings to the table around portability, sandbox security, and polyglot capabilities.
So you've walked right back to a question I wanted to bring up again. The two of us, we've got a ton of experience in containers. We know them like the back of our hand. But what's interesting in talking about C groups and this part of how it's actually built into into a kernel, previously you were saying it was baked in. I'd love to hear from you a little deeper on where you see WASM in this particular little example, from the point of view of, yes, so C groups were there for ages before they were used, but they weren't actually used and they weren't tested and they weren't put into production. The result of that meaning that every 6 to 10 months we see another container breakout, right? If you look at Kubernetes, They're still just getting going with the concept of seccomp in there. So they're still just trying to figure out how to use these type of things. WASM is a language which is new and built for security with the ground up, which most things aren't, unfortunately. How do you see the maturity of the language, or what's that going to look like, do you think, over the next 12 to 18 months?
Well, I think by design, so I gave the keynote at KubeCon EU. It was the Friday keynote, so it's supposed to be the forward-looking future keynote. And I actually called it WebAssembly and Cloud Native Better Together. Because what I'd like to point out that when you're taking something new to market, you have to think about, where do my users live today? And very specifically in the way that we have curated the content in the CNCF and the way that we have gone to market with wasmCloud as an open source project is we have really focused on the compatible with but not dependent upon story. So the first point I would want to make is that if you're interested in experimenting with these technologies, you can do this already today. We just released a Helm chart for wasmCloud a few weeks ago. We are going to announce on Wednesday of this week that we're releasing a set of Nomad packages. So regardless of what your orchestrator is, this ecosystem is compatible with. And you can take wasmCloud, which uses WebAssembly, and put that in a container, and you can run that on Kubernetes, and you can have that in a virtual machine, running in the cloud provider of your choice. It can be turtles all the way down, and Yertle's got nothing on these turtles, baby. You can have, because what I mean by that is all of the security controls that you're baked into your enterprise and you've built around your CI/CD pipelines and your scanning, all of that can be brought to bear on this powerful technology. And yes, you would still incur the initial startup penalty for the container, but once that container is going, you're really unlocking all of the rest of the value props around, low code, better maintainability, faster startup time. So the first thing is that I think you make a lot of wonderful points. And as a community, we can go to market with this now and make this just an additive layer. So we're just raising the bar with our existing stack. Now, separately, there is a whole movement, as you point out, and opportunities to run WebAssembly and wasmCloud in places where we don't run Kubernetes and in places where we don't run Linux. And to your point, I think that it's going to be an ongoing journey of things that we need to collaborate on together. But I'm really confident in the power of the Bytecode Alliance, which is an industry association around WebAssembly, as well as significant stakeholders like the CNCF, wasmCloud, and Cosmonic, who's the primary sponsor of WebAssembly, and our ability to help raise the bar in this space. Did that help to alleviate some of the concerns on the Better Together story?
Better Together, yeah. I was more curious about what you thought about the security maturity of WASM over the next 18 months.
Look, it's going to be iterative and continue to grow. Fastly announced on the WASM Time call. WASM Time is one of the reference implementations of WebAssembly as a standard that they had recently completed an audit with no major findings. They have not announced yet if they plan to release that or not, but I actually asked in that meeting if they would. Separately, through the CNCF, we're working to raise the bar around some of the public and clear testing against these things. So I think that there are some additional artifacts and processes that we need to continue to grow. WebAssembly is a very young community, but what I love about this audience and the listeners and the types of people that show up on this call and are very passionate about application security, this is also a tremendous opportunity. So I would hope that people hear this as a call to action and say that just as the cloud transformed how we do business, and just as containers transformed how we do business, I personally believe, because WebAssembly runs not only in and around the cloud and across the entire edge, that this is a significantly larger opportunity. That folks hear this as a call to action to think about the various skill sets that they have as their own capabilities, and to bring them to bear on a wonderful movement that is less of an evolution, and I think poised to be more of a revolution in technology.
No, that sounds like I don't want that sounds like a great way to end on a fine note. But I don't want just to be so abrupt. Maybe as one final follow-up question on that note, Liam. Is there something that you would call for participation in a particular project, be it wasmCloud or something else, or what would be some of the ways you would hope to grab more developers for direct collaboration or participation in this, to push this forward?
Yeah, I would call out 3 different places where I think that people of all types are welcome and that are really trying to build, large and inclusive communities of stakeholders to help usher in this revolution in technology. The first is obviously wasmCloud, which I'm very passionate about. You can go to wasmCloud.com. You can hop right in our Slack right there. We show up in a number of Discords, Twitter, all the places. We have community meetings on Wednesday at 12. The second place is the CNCF. We put wasmCloud into the Cloud Native Computing Foundation because we had, over 85 contributors, hundreds of using companies in our organization, and we'd sort of transcended that point where it really needed to belong to one organization. It needed to be into a foundation where we get shared governance, we get transparency. And within the CNCF, there were multiple amazing WebAssembly projects that are really focused at operationalizing this technology. And the third place is the Bytecode Alliance. The Bytecode Alliance is an incredible organization. It's really being driven by the creators of WebAssembly, and in my view, kind of owns the standards for the project itself. They work very closely with the standards bodies, and they're driving forward a lot of the community from there. So I would say if you're interested in the standards and the sort of core inner workings, the Bytecode Alliance would be a wonderful place to check in. If you're interested in its intersection of the enterprise and how we can operationalize this discipline broadly, the CNCF is already working on the Cloud Native WebAssembly Day for KubeCon EU in Valencia, Spain. And I will certainly be there with bells on. I hope to see many of you there as well. And then finally, if you'd just like to get in and start using the technology today and want to build some sample applications, I would encourage you to join us at wasmCloud.com.
That is awesome. Thank you so much, Liam. We'll make sure that we we update the show notes with a lot of those great resources you just listed off. But we also just want to tell everyone to go to the show notes and check out your bio and just give this a listen again, because you've given us a lot of great topics to think about. So thanks again.
Thank you so much for your time today. I really appreciate it.
I want to thank John and all of our listeners. We are going to take a quick break and return with news of the week.